Hello everybody, welcome to this first session of the statistics component of Sci 3402, where I want to do a couple of things. Firstly, I'm going to give you an overview of the statistics component of the module before moving into a refresher of between participants ANOVA, between participants analysis of variance. So what I want to do first of all is give you that overview. Why focus again on statistics? Well, the way I think it's helpful to think about this part of the module, what I want to do with it really, is to give you what I'm calling an integrated refresher on data analysis in the context of doing research. So for our purposes, that will involve some revision of techniques that you will already be familiar with from previous years, such as analysis of variance and regression, although with some newer twists, before leading into some newer material, such as using mixed models to analyze data with repeated measures, and also mediation and moderation. And we'll be doing that using Jamovi, which you'll be familiar with from the past couple of years. We are assuming, or I'm assuming, that you are familiar already with things like significance, variance, basic statistical concepts like that, and also that you're familiar with the assumptions underlying a lot of the tests that I will be showing you. So assumptions to do with parametric statistics, such as homogeneity of variance, equality of variances between conditions in factorial designs, and that sort of thing. Okay, so I won't be going over that stuff. The assumption is that you're familiar with that already. If you're feeling a little bit shaky on it, then yeah, go back and have a look, do a little bit of revision, and come back. But I won't be covering that directly. So just to unpack what I mean a little bit by an integrated refresher on data analysis in the context of doing research. So what I want to do is perhaps a little bit different to how maybe statistics is typically taught. We're aware that sometimes it is delivered in a way that makes it feel a little bit removed from the stuff that we are actually interested in. We're here because we're curious about the world. We're curious about human behavior in its various different forms. And then coming across statistics in the course of your degree can feel a little bit like an add-on. Okay, it feels a little bit removed from the actual substance, the stuff that we're really interested in, to satisfy our curiosity about the world. So what I want to do, or what we wanted to do in this module as a whole, is to take that statistical aspect of doing research, that analysis aspect of doing research, and put it a bit more explicitly back into the context of the research process as a whole. Okay. One of the great things about psychology as a discipline, as a science, is the ability to go out and actually investigate, to try and satisfy our curiosity about the world, to find out how people behave in all various different ways. Okay, and part of that is the design of research and the analysis of the data that we get from research. Okay, so I think it's very helpful to think about statistics as simply another tool in the toolbox of research methods, approaches to doing research that help us to find out about the stuff that we're really interested in about the world. Okay, so in slightly more concrete terms, what we're going to be doing over the next few weeks is, first of all, in this session, I'm going to be covering analysis of variance for designs with between participants aspects, so fully between participants designs. And then also in the last part of this session, I'll be covering effect sizes. Then next week, we'll be turning our attention to designs that have repeated measures elements and using mixed models to analyze those data. Then in week 9, I'll be shifting to talking about regression. So some of that will be covering material that will be somewhat familiar to you, particularly from last year, but then moving into newer approaches such as cross-lagged analysis of cross-lagged panel designs as a way of trying to strengthen the causal inferences that we can make from our analyses. Then in week 10, I'll move on to consider mediation and testing indirect effects between multiple variables, before in week 11 moving on to consider moderation, so a slightly different term from mediation. In week 11, I'll be focusing on moderation, with continuous predictors. Okay. So as I said, over the course of the module, we'll be using Jamovi. You will be familiar with that, hopefully, from the last couple of years. But if you do want a refresher, there's a link to a very basic user guide via the YouTube channel for the module. But in addition to the basic sort of analysis options you get with Jamovi, the key thing I want to point out here is that we will be using 2 additional modules which will need to be installed on your copy of Jamovi. The first of them is GAMLJ 3. So that's General Analyses for Linear Models, version 3. So there's a GAMLJ, make sure you get GAMLJ 3. Okay, that's the key one. So we'll be using that this week and next week, for example, for ANOVA and for mixed models. And we'll also be revisiting it in week 11 for moderation analyses. The second additional module that it would be very useful to have by the time you look at the videos is the JAM module, so Advanced Mediation Models. And we'll be using that quite a bit in week 10 when we turn our attention to mediation and indirect effects. Okay. So I just want to point you also towards some additional resources that are available to you on the module LE page. So I've included links, first off, to various YouTube channels and playlists delivered by other colleagues at different universities. Those cover some basic and also some more advanced statistics techniques. And also on the page, there's a link back to the LE page for the statistics module from last year. I've also included some introductory materials for techniques not covered in the current course, but which you might potentially be interested in the context of your research dissertations this year, for instance, or if you want to pursue further study in psychology and research. So I have flagged how to look at things like exploratory factor analysis and structural equation modeling, amongst other things. Okay. None of that is going to be covered directly in this module. They're just signposts for anyone who's interested in following up on those. One other very useful resource flagged on the LE page is Daniel Lakin's Improving Your Statistical Inferences online course. So that's a completely open and free course available via Coursera. And he covers things like how to interpret p-values correctly. I guess the key thing is they are actually quite difficult to interpret correctly, to pin that down. He says quite a bit more than I will in this module about effect sizes. And it's also a very nice introduction to other approaches to data analysis, such as using Bayesian statistics as an alternative to p-values and null hypothesis significance testing, and also an introduction to other topics such as open science. So, just before we get going into the specifics of, I start reintroducing between participants analysis of variance again, I just want to emphasize 2 core messages for this part of the module. So core message 1 is to think about analysis from the outset when you're designing a piece of research. This goes back to that idea of an integrated refresher, all right? That idea that statistics and analysis is best thought about right from the start in the context of the research process as a whole. So when we think about what we need to actually adequately test the hypotheses that we have, to test our ideas, we need 2 things. Firstly, we need to design an appropriate study. We need to set up our study in the correct way. Okay, we need appropriate research methods. And then once we've gathered data, we also need to analyze those data in appropriate and meaningful and informative ways. And what we'll see, or what you have been seeing over the course of the module, is that the design of studies is often explicitly about setting up or enabling specific ways of analyzing data. Okay, so researchers, when they're designing studies, are thinking already about how to analyze their data right from the outset in the way in which they set the study up. Not as an afterthought, not once the data are in, starting to think, oh, actually now, how should we analyze these data? Actually, they will have a very good idea of how they will approach that right from the get-go. So for example, they will be thinking about the analysis implications of whether there are manipulations in their study. Okay, whether their independent variables are categorical or continuous, and likewise for their dependent variables. Okay, so analysis, statistical analysis is something to be thought about right from the start in the context of all the other decisions we make about how to set up a study. Now, the second core message is that every technique that I'm going to cover in this module you can think of as a form of general linear model. Okay, they'll have various different names, all the techniques that I cover, as I mentioned earlier. They will involve different steps and options in Jamovi, but fundamentally they are all just different variations of a general linear model approach to analysis. Okay, so when we think of things like t-tests or ANOVAs, mixed models, or correlations, regression, some of the stuff that we'll come across later in the module, like mediation and moderation, they're all actually really closely related. They are not fundamentally different things. Okay, and in fact, they all are instantiations of a general linear modeling approach to analyzing our data. So how can you think about the differences between these? And there are differences. Well, actually, the main differences, I think, are just simply in terms of, on the one hand, how we set up and specify the model that we want to test. So, for example, what our theory, or theorizing, tells us about the relationship between the different variables that we have, our independent variables and our dependent variables. And secondly, the specific options. This is just a pragmatic difference. The difference between these techniques is often just boils down to which options you choose in Jamovi to test the model. A pragmatic decision based on which option is going to give me the different bits of output that I most want given the questions that I'm asking of my data. Okay, so these differences aside, fundamentally a key thing to remember is all of these techniques that I'm going to be talking about are different instantiations of the same analysis approach, general linear modeling. So when we are designing a study and thinking about analysis of the data that we're going to gather, we need to consider the options that we have given how we're setting our study up. So one thing to emphasize is that across all of the techniques that I will be talking about, a key assumption is that the dependent variable or outcome variable is continuous. It's a measure of something. It's not categorical. It is absolutely possible to do analyses on categorical outcome variables. It's just that I won't be covering any of those in the context of this module. Okay, so that's an assumption. From there, though, there are various other things that we need to think about. How many independent variables do we have? And are those independent variables categorical? So, for example, are they manipulations or are they categorical predictors like gender? Remember, a categorical variable is one in which the numbering of different levels is arbitrary because those levels differ in terms of their quality, not in terms of their quantity. Or on the other hand, are those independent variables or predictor variables continuous? So for example, are they measures of variables such as income, if we're interested in things that are affected by income levels? Secondly, we might consider whether there are any repeated measures aspects to our design. Or do we have any repeated measures variables? So for example, in our design, do participants complete the same measure at several different time points? Or perhaps do they provide scores on the same variable under different experimental conditions? Okay. And finally, we also need to think about how our independent variables, if we have more than one, how they actually relate not just to the dependent variable, but how they relate to one another. Are they correlated, for example? And do they potentially affect one another? Okay, does one independent variable affect another independent variable, which might be the case in a mediation design? Or alternatively, does the effect of one independent variable change the effect of a second independent variable, which would be an example of moderation? So all of these things which we're dealing with conceptually at the sort of the research design stage, the theorizing stage, have a clear and direct impact on the analysis options that we have when it comes to looking at our data. Okay, so that's the sort of what I want to do in broad terms. Okay, that's the agenda of the module. Now, what I'm going to do for the rest of, for most of the rest of this week's session before getting into effect sizes is I'm going to reintroduce analysis of variance for between participants designs. So just to remind you, between participants designs are designs in which participants contribute only one data point to each dependent variable. So for example, in the context of an experiment, the participant will have taken part in only one condition. Okay, so the twist here is, you'll be familiar with ANOVA in general terms, of course, from the past couple of years. I'm going to be talking about analysis of variance as a general linear model. Okay. So another feature of what I'm going to do each week, all right, to try and get that sense of statistics as something that is embedded in the broader sort of enterprise of finding out the things that we're interested in, what I'm going to do to illustrate or exemplify the techniques and the analysis implications of design decisions is I'm going to start with a research question, okay, and then I'm going to look at how you can perhaps test that research question or examine it in the most basic terms design-wise. And then I'm going to consider how changing the nature of that design, so for example, maybe making it more complex, adding more nuance to it, how that in turn impacts at each step on the analysis options that you have as a result. Okay, so I'll start simple with a very simple research design in each case to address a research question, and then sort of layer in complexity as we go along to look at how that shapes how we should analyze the data. Okay, so in relation to analysis of variance, I'm going to start with a research question that actually relates to my own research interests. And specifically, what is the effect of group status on perceptions of conflict between groups? Okay, so when might we perceive a group that we belong to as being in conflict with another group that we don't belong to? So one answer might be it depends on the relative status of our group relative to that other group. If our group has relatively low status, if we feel relatively disadvantaged relative or compared to another group, then perhaps our motivations might guide us towards thinking about ways of sort of shaking up the status quo, about rectifying that imbalance. So we might perceive, or we might be more ready or more open to perceiving tensions or conflict between the group. Okay. In contrast, if our group has relatively high status compared to another group, then perhaps our motivations are about maintaining the status quo between the groups. If that's the case, then perhaps we don't want to rock the boat. We want to keep things relatively stable and secure in terms of relations between the groups. Therefore, we're more inclined to play down the existence of conflict and to characterize the relationship as being a bit better than we might otherwise do. Okay. So, to test that idea, we might posit a hypothesis in the following terms. Group members will be less likely to perceive conflict with another group when their in-group, the group they belong to, has relatively high status. Okay. So in a very simple design, we might manipulate that independent variable, group status, to have two levels. Okay. So participants are randomly allocated to a condition in which a group they belong to has high status, or a condition in which that group has low status compared to another group. Okay, so it's a simple design because the operationalization of the independent variable only has two levels, two conditions. Then, as an outcome variable, as a dependent variable, we might measure perceptions of intergroup conflict via a questionnaire. Okay, so schematically, we might represent the design and the prediction as follows. We've got a dependent variable. We've got our two levels, two conditions of the independent variable, high status and low status, and the prediction represented here that we're going to perceive more conflict, higher scores in this condition, the low status condition, than the high status condition. So, given that relatively simple design, what are our analysis options? Okay, well, there's actually a couple. we might run an independent samples t-test or a one-way analysis of variance. Okay, I'm going to show you both of those in action. Okay, so I'll just skip over to Jamovi. So here we have a data set. Okay, so I'm going to start with a t-test in the first instance. Okay, so we've got two conditions, which means that we can run a t-test. We have perceptions of intergroup conflict as a continuous dependent variable, and our grouping variable, okay, is our independent variable, in this case in-group status, which has two levels. So the basic outcomes of the t-test there. I'm going to also ask for effect sizes and descriptive statistics as well. Okay. Now I'm going to show you the same analysis using a one-way analysis of variance. Excuse me. But rather than going to the default ANOVA option from Jamovi, I'm going to go to the linear models option, which appears when you install, via the modules option here, when you install GAMLJ 3. Okay. And from this menu, I'm going to choose General Linear Model. When we do that, we get the following options to set up our model. So again, conflict is our dependent variable, perceptions of conflict, and in-group status is our factor. So a factor in this setup is simply an independent variable that is categorical, which is indicated by this little icon here. So in-group status is a categorical variable, it's a manipulation. So that goes in the factors box. Okay. And there we have our ANOVA output in basic terms. One other thing I would encourage you to do is ask for the estimated means, the descriptive statistics for your independent variables as well. Okay. And that appears down at the bottom. Okay. So key things about these outputs, t-tests versus analysis of variance for the same model. Well, again, as I've emphasized, these are both actually just instantiations of a general linear modeling approach to doing our analysis. They are fundamentally the same thing, okay, as we will see from the output. So here is the key output from the t-test, and here's the key output from the ANOVA. One first thing to highlight is that the p-value for the test is identical, and the F ratio you get in the ANOVA is simply the t-statistic squared. Okay, these analyses are functionally equivalent. They are just different variations on the general linear modeling approach. So they're fundamentally the same thing. They're going to give you exactly the same answer in functional terms. All right. So I guess one message there is, if you have a design like this and you want to run an ANOVA, don't also run a t-test or vice versa, because that's going to be redundant. Okay. So the analysis of variance approach comes into its own a little bit more with slightly more complex designs. All right, so let's go back to our research question and make it slightly more complex in terms of the hypothesis or prediction. Okay, so here we're suggesting or testing the idea that group members will be less likely to perceive conflict with another group when their own group has high or equal status relative to another group. Okay. So to test this hypothesis, we might operationalize it in a slightly more complex design, where we manipulate group status, but this time to have 3 conditions rather than 2. So we've got a high and a low status condition as before, but now we also have an equal status condition. Schematically, we can represent it as follows. Our dependent variable is going to be higher, we predict, in this condition compared to the other 2 conditions. So our analysis options here, again, a one-way analysis of variance. Now, when we have more than 2 conditions, that one-way ANOVA allows us to, well, it provides us with an overall test of the effect of the independent variable, but it also allows us to dig down a little bit further into the results and give us tests of specific comparisons between individual conditions or combinations of conditions. For example, comparisons specifically between the high and the low condition, or the equal and the low condition. Okay. Just before I show you that in action, one thing I just want to highlight is the factors coding option in the GAMLJ drop-down menu for general linear modeling. Okay. So under factors coding, you can change the default simple coding option for your independent variable, your categorical independent variables. So that default simple coding gives you pairwise contrasts involving the first level of your independent variable. But you can change that, and you've got various different options, as we will see. So for example, we might change it to what's called Helmert coding, which asks for contrasts between the first level versus all other levels combined, and then of each subsequent level compared to the combination of all subsequent levels that come after that. Okay, so in our design, that would give us a contrast between the low versus the equal and high conditions combined, and then a comparison between the equal and high condition. Okay, so just to sort of break that down a little bit in slightly clearer terms, hopefully, the coding types for factors that we'll come across in this module, well, we'll also come across polynomial factor coding, but for our purposes here, the default is simple coding, which will compare in our design with 3 levels, the first level of your independent variable, for example, the first condition, with each subsequent level in pairwise terms. So for instance, it will first compare level 1 versus level 2, and then it will compare level 1 versus level 3, ignoring level 2. In contrast, Helmert coding compares each level or condition in your design with the average of all subsequent levels. So if we have 3 levels, what that will do is firstly compare level 1 with levels 2 and 3 combined, and then it will compare level 2 versus level 3, ignoring level 1. All right. And finally, the difference coding options does something quite similar to Helmert coding, but almost in reverse. So what it does, it compares each level or condition in your design with the average of all preceding levels in the design. So in our design, for example, that would first compare level 2 with level 1, okay, and then level 3 with each preceding level combined. Okay, so level 3 versus levels 1 and levels 2. So these different coding options allow you to test different combinations of pairwise comparisons between conditions. So for example, condition 1 versus condition 2, condition 1 versus condition 3, or 2 versus 3, or combinations of conditions. So for example, 1 versus 2 and 3 combined, or 3 versus 1 and 2 combined. All right. So let's see that in action. So back to Jamovi. Now again, here we have in-group status, we've got conflict, but this time status has 3 levels: low status, high status, and equal status. So again, we're going to go to linear models, choose general linear model. Once more, conflict is our dependent variable and in-group status is our factor. Okay. I'm going to choose marginal means for status. Okay. So before we change anything else, let's just have a little look at the output. So we have our ANOVA table, which shows that there is indeed a significant effect of in-group status on perceptions of conflict. We have the marginal means here, which give us some sense of the pattern of that. So perceptions of conflict are higher, descriptively at least, in the low condition than in the equal condition. And the high condition is also, well, sort of in between the equal and the low condition. Now, by default, as I said, the coding option for in-group status is simple coding. And that gives us, in this additional table called parameter estimates, it gives us pairwise comparisons between the low condition, the first level, and each of the others. So this first contrast is between the low condition and the equal status condition, which is significant, and the low condition versus the high condition, which is not significant. Okay. Now, our specific hypothesis was about the low condition versus the equal and high conditions. So one analysis option there is to compare the low condition to the equal and high condition combined. So to do that, I'm going to change it to Helmert coding from simple coding. Now, the overall ANOVA table is completely unchanged. It's the same analysis, but the contrasts that we get in this table are now a little bit different. Firstly, it gives us a contrast of the low versus the equal and high status conditions combined, which is not significant, and a comparison of the equal and the high condition, also not quite significant. Okay, so let's just look at that output in slightly more zoomed in terms. We have a significant overall effect of in-group status, but delving down into that specific contrast implied by the hypothesis, the contrast of the low condition to the equal and high conditions combined was not significant. Okay. Actually, one other thing I want to show you is how to get descriptive statistics with standard deviations for this type of design. Okay, so I'm just going to pop back to Jamovi. Okay. Now to get means and standard deviations for this design rather than standard errors, you can go to Exploration and Descriptives. And here I'm going to enter our outcome variable as the variable, and I'm going to ask it to be split by a categorical variable, which is our manipulation of status. Okay. Now this is a big long table by default, so I'm going to simplify it. I'm going to change it from variables across columns to variables across rows. And I'm going to reduce the amount of information that it gives me. I'm going to say, oh please, I don't want to know about the missing values. I don't want to know about the minimum or maximum or the median. Okay. And now we have a nice clear table telling me the mean and the standard deviation in each of those three conditions. Okay, so that's where the table comes from. Okay, via exploration and descriptives. So let's layer in another bit of complexity into our design. And this is important because when we think about all the stuff that we might be interested in about the world, about human behavior, human behavior is pretty complex, and often our theory and hypotheses want to reflect that complexity. For that reason, they often also specify that it's more than one independent variable that affects our dependent variable. The stuff we're interested in has multiple sort of interlocking causes. Right. And more specifically, not only do we have more than one independent variable, we also might reason that the effect of one independent variable might depend on or change as a function of another independent variable, a second independent variable, or even a third independent variable. So when we hypothesize or theorize something like that, in analysis terms, what we're suggesting is we're expecting an interaction effect, okay, an interaction between two or more independent variables. Okay, so an interaction effect simply reflects our reasoning that the effect of one independent variable will in turn be different at different levels of another independent variable. So let's make that a little bit more concrete in terms of that research question that's guiding us through this lecture. Okay, so we've got that basic prediction that group members will be less likely to perceive conflict with another group when their own group has high status. But now we're suggesting that that effect will only occur at specific levels of a second independent variable, namely whether people believe that their responses, their answers, are going to be seen by members of the other group or by members of their own group. Okay, so in these terms, whether they believe they're addressing an outgroup audience or their own group. Okay. So here now, this hypothesis suggests we have two independent variables. We've got status that we saw before, high versus low, but we've also got a second independent variable of audience, whether our responses are going to be seen by in-group members or out-group members. And specifically, the hypothesis is suggesting that the effect of the first independent variable is going to depend on the second independent variable, an interaction. So schematically, especially when we've got more than one independent variable, this sort of schematic representation could be quite useful. So here we're suggesting that sort of horizontally here we've got the effect of status, okay, the comparison between the high status and the low status condition. Now this breakdown is suggesting that, well, in our dependent variable we're not expecting really any difference between those conditions when people believe that they are addressing an in-group audience. In contrast, when they're addressing an out-group audience, we expect to see that effect of status really kick in. Okay, we're expecting to see a difference in terms of perceived conflict, where perceived conflict is higher in the low status condition than the high status condition. Importantly, that's only happening in the out-group audience condition, not the in-group audience condition. Okay, so our analysis options here, a two-way analysis of variance. So just to reiterate, in case there's any ambiguity or confusion here, when we talk about a one-way or a two-way or a three-way analysis of variance, that number refers to the number of independent variables in the design. Okay, so a one-way ANOVA has one independent variable, a two-way ANOVA has two independent variables, and so forth. Okay, so in a two-way design, a two-way analysis of variance, we're going to end up with three effects. Okay, two of those effects are the respective main effects of the two independent variables. Those main effects are the effect of that independent variable collapsed across all levels of the other independent variable. So the main effect of status is the effect of status. Okay, this difference collapsed across all levels of audience, that second independent variable. And the main effect of audience is the effect of audience, this comparison collapsed across all levels of status. Okay. The third effect that you will get in this design is the interaction effect. The interaction effect is the test of the extent to which the effect of status varies or is different as a function of audience. Okay, it's a test of whether the effect of one independent variable is different at different levels of the second independent variable. Okay, so let's look at that in action. Back to Jamovi. We're back to our first data set here. So now I'm going to go to, again, linear models, general linear model. Once again, I'm asking for conflict perceptions as our outcome variable. Status is our factor, our first factor, and our second factor now is audience. Okay. Now we have a two-way design, two independent variables. I'm just going to ask for the means for status, for audience, and for status broken down by audience as well, just to move that across. And there's our ANOVA output, okay, and the means at the bottom. So I'll just pop back to Jamovi to run through that output. So what we have are our three effects, the main effects, okay. Neither of those are significant, nowhere near significant. And the main effects of status and of audience are both non-significant. In contrast, though, the interaction between them is significant. Okay, and here's how you would write that effect up in APA format. So that's it for the first part of this week's session. In the second part, I will be going into how we can delve further into that interaction to offer a more specific test of the hypothesis using simple main effects. Okay, so I'll see you for that second part.